Welcome to Sundar's lecture. This is lecture number 84B. Actually, in the previous class, we have started with the steady state analysis of coupled coils, and we have seen this operator will be equivalent to j omega, and whatever the j omega terms you take, you can directly write the KVL expressions, right? So, we have seen few problems, this one and this to find I1 and I2 an easy problems, right? We found what is the voltage across this 5 ohms reactance and all those kind of things. See, we will continue, we will take some more problems so that you can get a good clarity in the coupled coils, right? So now see, find V2 by V1, find V2 by V1 for which I1 is equal to 0, right? So what you do, you just find the equation I1 and also for I2, and then you put I1 is equal to 0 in those two equations, you will directly get V1, right? You just write KVL expression, right? KVL expression, right? So for loop 1, so first I will write the KVL for loop number 1. See, try to understand one thing. Here, you no need to put I1 minus I2 on those kind of things, because this is a separate circuit. This is a separate circuit unless whatever we have seen here, since this is the same electrical circuit, you have to write I1 minus I2 here for first loop and I2 minus I1 for the second loop. Try to understand. That is for these kind of circuits, and we have written here too, and we have written here too. See here, here. But the point is, now this is a separate circuit, this is a separate circuit. Try to understand. Whatever the current flowing here, it is I1, it is I2. That's all. Very simply, you can uh, do these kind of things. See, this one will be I1 and this one will be I2. Simply, no need to put I1 minus I2 on those kind of things, right? So now what we do, we try to write the KVL expression, right? So there is a voltage and current is traveling from minus to plus here. So it is V1. It will be V1. So V1, which is equal to, and the current is flowing in the 5 ohms resistor. So it is 5 into I1. It is 5 into I1. See here, this is coupled coil now, and I need to write the self-induced EMF as well as mutually induced EMF. See, if you want to write the self-induced EMF, this is plus, straight away plus 8j into I1, 8j into I1. Simply, right? I don't need to see any current directions or through dot, whatever it may be, right? Now I need to write the mutually induced EMF. See, here the current I is entering through dot, and see the second coil, the mutually coupled, because this is coupled, right? So now this current is actually leaving. If I put I2, it will come like this, right? So this current is leaving the dot. So what I have to put? I have to put minus. It is 2j, 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 and what is the current in the second coil? It is I2. That's all. No other components are connected. So straight away you put, this is equation number 1. That's all. So now you write KVL. These problems are very easy to KVL for loop 2. Loop 2. So what it will be now? I will start here and then I will go here, come here, all those kind of things. See here, you have a voltage, but in voltage you see the current is traveling from plus to minus, plus to minus. So what you have to put? You have to put minus V2 here, simply. Don't put plus V2, that is wrong, because here current is traveling from minus to plus, but here traveling from plus to minus. So it is minus V2. Then this current, it is 2 into I2, 2 into I2, that I have written. Now I have to write the self-induced EMF and mutually induced EMF for this one. This coil 2j ohms. See this one, this is plus, straight away plus, because the self-induced EMF I always use plus. So it is 2j. What is current flowing here? It is I2. It is I2. Now I need to see the mutual induced EMF. I need to write the mutual induced EMF, so I need to see the current direction. See here, this current is leaving dot, but this current is entering dot. Straight away I have to put minus, and then mutual coupling, mutual reactance, that is 2j. What is current here? It is I1. That's all. With So this equation is number 2. See, what is the question they have asked you? They are asking what is the ratio of V2 by V1 when I1 is 0. See, put I1 is 0. See, anyhow, equation 1 can be written as what? V1 can be written as, you take commonly I1 outside, so it will be 5 plus 8j into I1 minus 2j I2 and if I put I1 is equal to 0 for I1 is equal to 0, the equation V1 will become now minus 2j I2 simply, right? Make it as expression number 3, and then for this expression in this one, you just put I1 is equal to 0, and what happens to minus V2? Minus V2 will be is equal to I1 will go off, and you will have only 2 plus 2j into I2. Only this one. This is expression number 4. So what you do now, you just divide 4 divided by 3. What you will get? Minus V2 by V1 will be is equal to minus V2, it is a 2 plus 2j into I2 divided by minus 2j into I2. Right, this is the equation. See, this 2 I2 will be cancelled out, this 2 and this 2 will be cancelled out, and if I simplify this, V2 by V1 will be is equal to, I am getting it to be 1 minus j volt. You try to understand these kind of problems. If you write KVL expressions, very simple, and also the transformer like problems, that is coupled coils problems, not in the same circuit, in electric circuit, it is very easy to understand, right? We will go to the next one now. Simply we will go to next one. See, what is the question they are asking you to find Z seen from source. That means what? This one, right? Z seen from source means you need to find Z is equal to, that means Z1, maybe I will take it as Z1 because this is circuit 1, this is circuit 2. Z1 is equal to V1 divided by I1. I need to find this ratio, right? I know what is V1, that is 80 volt, that was given here, right? So source voltage has been given. I need to find what is I1. Simply if I find what is I1, then it is easy to put these values here. Anyhow, for whatever it may be, you have to write the KVL expressions and you need to go with the same procedure. See, I will write KVL for loop number 1. KVL for loop number 1. Simply, these kind of problems are very easy, right? So anyhow, I will write 80 volt is here. The first loop has 80 volt. I will go fast now. So 80, which is equal to, see this current, what is this current? This is I1, right? Simply, right? It is I1, so it is 4I1. It is 4I1, and I need to write the self-induced EMF. See, current is traveling like this. This is I1, and this current is I2. This is I2. I have to write the self-induced EMF. I straight away put plus 5j into I1. That is self-induced EMF, and I need to see the mutual induced EMF. See here, this current is leaving the dot here, and this current is also leaving the dot, right? This is I2. So both are leaving dot. So what I have to put? I have to put plus this mutual coupling, mutually coupled reactance, that is 2j. What is the second coil current? It is I2. It is I2, right? This is I2. That's all. I have written this one. So this is maybe if further simplification is needed, so I will write it here. 4 plus 5j 4 plus 5j into I1 plus 2j into I2, which is equal to 80. This is equation number 1, simply, right? And then if you are going for a KVL at loop number 2, for this particular loop, I need to write the KVL expression, right? So I will start from here. I will start from this point. So anyhow, there is no voltage, right? No voltage sources are available in the second loop. So straight away you put 0. That's all. Straight away you put 0. And this current, it is 4 into I2. 4 into I2. and this one will be minus 1j into I2. See here, try to understand one thing very clearly. This coil don't have mutual coupling. So what will not come here? There will not be any mutually induced EMF. Try to understand. Don't confuse. See these two coils, they have given you dot convolution is there and it is coupled one. Since if it is coupled, then they will give you the coupled reactance, right? Mutually coupled reactance value will be given. But for this coil, they didn't give anything. Since this coil is not connected, this is an inductor. Simply it is an inductor. That's all, right? So you have to write plus only self-induced EMF will be there. It is a 2j. 2j. What is the current coming here? Simply it is I2, right? I2. That's all. Self-induced EMF. Simply self-induced EMF. And then I have to go to this coil. I have to write the self-induced EMF. It is 5j is here and it is I2. Current is I2. See, this current is leaving dot and this current is also leaving dot. Straight away you put plus and the 2j, and what is the current in the second coil? It is I1 simply. And if you further simplify this, so I'm not going to give you exact simplification. I will directly write the equation. So you will get an expression like this. See, what I need here, I need to find what is the value of I1. So I need to write in terms of I2, right? I have to write I2 in terms of I1. So what is I2 here? I2 can be written as minus 2j I1 divided by 4 plus 6j. 4 plus 6j. That's all. This expression. This is expression number 2 now. So now what you do? Simply you substitute expression number 2 in 1. What will you get here? So it is 4 plus 5j into I1 and then plus 2j multiplication of minus 2j I1 divided by 4 plus 6j, right? That should be is equal to 80. And you see here, both are I1 terms, and if you simplify this one, you will straight away get the I1 value. So I will write it here. I1 is equal to, I am getting I1 to be 8.8025 minus 9.272j. So I am not giving these kind of things. See, try to understand. I am not giving. Why? Because it is easy to simplify. Just simplify algebraic things. You do it by yourself. So now if I want to find what is the Z value, Z which is equal to what? This is 80 and I have found what is I1. So 80 divided by 8.8025 and this value minus 9.272j, right? If you simplify this, you will straight away get what is the value of Ez. So Ez which is equal to, I am getting it to be 4.308 plus 4.538j, maybe this one, j ohms. So this is the value of Ez I am getting, right? So we found, right? Seen from source? Seen from source? We have found the value, right? So now we will go to the other problem. See this one. We need to find what is the Norton's equivalent circuit. Right? So if you want to find the Norton's equivalent circuit, what is the Norton's equivalent circuit? And you know these kind of things. We have seen these kind of things already, right? So Norton's equivalent circuit will be, I will draw it down. See, I have just drawn the Norton's equivalent circuit and I need to find what is IN and I need to find what is the value of ZTH, right? Across these 2 points, right? So, to find IN, what is the procedure? To find IN, what you need to do? You have to short circuit these 2 points, right? Short circuit AB and find, maybe I will just do this. You just short circuit and find what is the current flowing here. So what is current flowing here? It is I1, right? Sorry, IN. This is the IN. Maybe now this is 2 loop problem, right? So let this one be I1 and this one be in, or I2, I will take I2 and I straight away put what is I2, that is nothing but it is in. So what you need to do, you just write down the equations and you just substitute the values. You will obviously get what is the value of I2, right? So if I do so, I have to write the KVL expression for the loop number 1. So KVL for loop number 1. What I will get straight away, I will just write it down. So you have a voltage source, so it will be 100 at an angle of 30 degree, which is equal to, I am going very fast, so it is 20 I1, it is 20 I1. See this current, now it is very, you have two loops and you have to write this as now I1 minus I2 for the first loop. So what is the current coming to this coil? It is I1 minus I2 into the value of this one. This is self-induced EMF, and then you see here this current is leaving dot, and you see this current. This is nothing but I am calling it as I2, and this current is also leaving dot. See, since if it is short circuited, then this current is also leaving dot. This current is also leaving dot. So this is plus 10J I2. Not 10J. This value. This is 5J. Self uh, mutual coupled reactance, right? 5J I2. That's all. I have written this is self-induced EMF, mutual induced EMF completed. This is the equation. And if you simplify this equation, I will straight away write it down. So 20 plus 10J into I1 minus 5J I2, which is equal to 100 at an angle of 30 degree, right? This is equation number 1. And if you go for equation number 2 for KVL for this particular loop, so KVL for loop number 2, So what you will get is simply, there are two inductances, right? Two mutually coupled inductances. Maybe I will write it down for first for this one. So what I will get for this one, self-induced EMF will be maybe no voltage sources are there. So straight away you put 0, which is equal to this one. It is 20 JI2. That is self-induced EMF. And you see the now this current, it is I2 minus I1, right? This is I2 minus I1, and see, I have to see this current is leaving dot here, right? This current, but you see this current is entering dot. So what I have to put? I have to put minus. What is the coupling? Mutual coupled reactance. It is 5J. And what is the current in the second coil? It is I2 minus I1. I2. A second coil means other coil. Right, I have written for this one and I have to write for this one now. As straight away I put plus for the self-induced EMF, right? What is the current is flowing here? It is I2 minus I1 multiplication of 10J. So that is self-induced EMF. And you see this current is entering dot, this current is leaving dot. So what I have to put here? I have to put minus. See, straight away. It is 5J. What is the other coil current? It is I2. This is mutually induced EMF. See this one now. I have just completed for both coils, and I can easily find what is the equation for I1 is equal to I2. Straight away, I can write it down here anyhow. I am getting it to be. So I will just straight away write this equation. You will get 20 JI2, which is equal to 5 JI1. If you simplify this, you will get this one. So what I can write here, I can straight away write what is the value of I1, right? So I1 can be written as 20J divided by 5J into I2, right? So this J and this J will be cancelled out, and simply you can write I1 will be is equal to 4 into I2. This is equation number 2, right? So now what you do, simply you just substitute this equation 2 in 1. Put I1 instead of this value, right? So what if you do so I will straight away write the answers in the next one. Put equation number 2 in equation number 1. and if you do so, you will get I2, that is nothing but is equal to, see what is I2? I2 is nothing but it is In, right? So I2 which is equal to In, which is equal to, I am getting it to be 1.145 at an angle of 6.52 degree amperes, right? See here, I found what is the value of In, right? Now what I need to do, I need to find the value of ZTH, right? So how will you find ZTH? Try to understand one thing very clearly. ZTH, you would have seen, we have seen all these kind of things in Norton's theorem. We have solved many problems. See, you please go through my Norton's theorem lecture, there you can find these kind of things. What is ZTH? Simply you can write it is VOC divided by IN. See, I know what is IN, right? So if I find what is the value of VOC, then what I can do, I can easily find the value of the ZTH by dividing these two, because I have this value. I have this value. Now I need to find what is VOC. What is VOC? Open circuit this one and find what is the voltage here. Find what is the voltage here, right? It is very simple, right? So I will take this one, a diagram I will draw it again. Right. Now you see I have taken this diagram. This is the diagram, right? So what is the voltage value? It is 100 at an angle of 30 degree, right? So it is 100 at an angle of 30 degree. See, try to understand, if I open circuit this one, the current in this coil becomes zero. So this coil doesn't have any current flowing through this one. So this mutual is also invalid now, and also you see this coil is only valid. So this is a separate coil now. This is a separate coil and there is no current here. So what happens here? This one becomes I1, and you see what is the voltage between these 2 points. This is nothing but what is the reactance I have here. So what is voltage between VAB? That is nothing but we can call it as VOC, and that is nothing but we can straight away write 10J is here, right? So it is 10J. Whatever dot you don't need to see here, because there is no mutual coupling, because this coil doesn't have current, doesn't carry current. So straight away this coil is invalid now. So it is 10J into whatever the current is coming here. That is voltage between these 2 points. Simply, I am going in this direction, B to A. So I am going here. This current is coming opposite to you, so it is plus 10J into I1. Simply. That's all, right? So if you know what is I1, then you can substitute here and you can find the value of VOC, right? So what is I1? You just write the equation. Simply apply KVL. Apply KVL. KVL for loop number 1. There is only one loop anyhow. So if you do so, what you will get? And what you will get? Straight away it is 10 100 at an angle of 30 degree. That is equal to, I can write this as now 20 I1. See this current, that is also will be plus. Only self-induced EMF, right? So it is 10J I1. Simply, right? What you will get here? 20 plus 10J. Maybe I will straight away write it down. Say I1 will be is equal to 100 at an angle of 30 degree divided by, if you take commonly outside, it is 10 plus 20 plus 10J. Simply. So what is the I1 I am getting here? If I do so, I1 I am getting it to be 4.464 plus 0.2668J. So now what you do? What is VOC? It is VOC can be written as 10J multiplication of 4.464 plus 0.268J. So simply if I do so, maybe I will take this color. So this is VOC. What is the VOC I am getting here? It is a minus 2.68 plus 44.64 J volt. This is ampere and all those kind of things, right? So now this is the value of VOC. And what is EZN now? EZN can be found out by VOC by or EZTH. I have written here EZTH anyhow. This is EZTH, which is equal to VOC divided by IN. See this one, this is minus 2.68 plus 44.64 divided by, and what is IN? What is IN? I have found. What is the IN? See here, it is 1.145 at an angle of 6.52 degree. And if I do so, what is the ZTH value? I am getting it to be 39 at an angle of 86.56 degree ohms. So you see here, you see this one. I have found both IN and the values of EZTH, right? So that is what they have asked you, right? We have found both values, and this is the Norton's equivalent circuit, right? So see here, for every problems, it is also easy to find the Norton's equivalent circuit. Even you go for superposition or you go for Thevenin's theorem, whatever it may be, you will get the answers, right? So we are just applying an electrical circuit theorems here in coupled coils, right? In coupled coils. So that is the beauty of studying the steady state analysis of mutually coupled coils. You have to convert them into an electrical circuit to find what is the current, what is the voltage, or what is the power, and whatever it may be. You have to convert them into the electrical circuit, and that is the main motive of this particular topic. That is why I have taken this much of time, this much of problems to solve, to get you a good knowledge about the coupled coils, right? What are the topics we have seen today, we have taken another three problems, right? This is we need to find what is the ratio of V2 by V1 for which I1 is equal to 0. Just write KVL expressions for both loop, put I1 is equal to 0, and straight away you will get the values of V2 by V1. And this problem is also interesting. You need to find what is Z seen from source. Simply it is V1 by I1. We know what is V1, they have given you already, and we find what is the value of I1 by writing the KVL equations for the both loops. And in this problem, we need to find Norton's equivalent circuit, right? So this is Norton's equivalent circuit. You need to find IN and ZTH, and we have taken the problem short circuit this one, get ISE or IN, and then open circuit this one, get VOC, and then you divide both things, you will get ZTH, and we have found what is IN, right? So we will go to the next topic in the next class, right? Thank you.